Hello, libp2p community. Today, we are going to dive into how libp2p enable decentralized AI through KwaaiNet, a network that connects petals framework, allowing AI models to be accessed via OpenAI compatible API. This makes it seamless for applications like OpenWebUI to interact with decentralized AI just as they would with centralized services. I'm Balaji, co-founder of Studio Bit and advisor to Kwai, and I'm excited to show you how this works. So let's talk about what's happening under the hood. KwaaiNet acts as a decentralized AI routing layer using libp2p for peer discovery, transport, and secure communication. This allows AI models hosted on petals to be accessed in a completely decentralized way without relying on centralized APIs. The key here is that developers don't need to learn a new protocol. They can just send requests as they would using an OpenAI compliant API. And KwaaiNet takes care of finding the best peers hosting the requested model for inference. KwaaiNet isn't just a decentralized API, it's a framework for permissionless AI innovation. The goal is to create an ecosystem where anyone can train AI models or host AI models, contribute compute resources, and query AI through a truly open network. Right now, we are focused on bridging with petals, but the idea is to expand beyond that, supporting multiple AI frameworks and even incentivizing compute providers through a tokenized reward system in the future. Okay, let's see this in action. Here I have a display set up with a map of United States showing how the nodes are distributed across the East Coast and West Coast. In the table view, you can see that no single node has all the blocks necessary to do the inference for the Llama 3.18 billion instruct model. There are direct nodes and relay nodes as well to cover all use cases. And to make it realistic, it is a live network that's spread across the wide area network. The network topology consists of bootstrap servers, API servers that host specific model and route these API requests to the nodes and get the response back. As you can see, the nodes are in all shapes and sizes, depending on whether it's a CPU, GPU, or something even more powerful in the future. To enable this demo, we connect the KwaaiNet API to OpenWebUI. So let's see this in action. Say I want to query a large language model running on petals via KwaaiNet. In this case, a Llama 3.18 billion instruct model. Here's what happens. The user sends a request via OpenWebUI, which is configured to use KwaaiNet as the backend. Here I have some examples, and I've set it up as a side-by-side with a local 8 billion and a KwaaiNet 8 billion to see how this all works. So let's pick a question. So the KwaaiNet's OpenAI compatible API receives the request. libp2p discovers available petals nodes that has the model to complete the request, and the request is routed securely to the petal node using libp2p. The model processes the query and returns the result back to OpenWebUI, just like OpenAI response. In this case, you see that the local 8 billion model responds faster as the number of requests increase and the parallel throughput is needed. I believe the KwaaiNet node will have an edge over the local model. This is just the beginning. We see Kwai as a foundation for much larger decentralized AI movement. Imagine a world where AI models are community hosted, trained, and not locked behind corporate paywalls. Anyone can run AI workloads on their own hardware and contribute to the network. developers can build AI applications without relying on a single centralized entity. This has been a great opportunity for us to showcase what we have built using lit P2P and petals under the KwaaiNet framework. Hope you enjoyed this presentation.